going to jump directly to AGM session.
Okay. Hello everyone. My workshop was about artificial intelligence and generative design. We had 22 participants from 12 different countries. Usually my workshops about AI is around 160 hours, so I had a big struggle how I want to deal with this 2 days workshop, but fortunately all of the participants had very good knowledge about artificial intelligence and how they want to cope. So I only have 5 minutes now. I want to go very quickly throughout the slides. Okay. First, we started about the concepts, the basic concepts of the AI, machine learning and deep learning, on what is supervised learning and what is unsupervised, and also semi-supervised learning. We talked about this in the class. And then we talked about the structure of the artificial neural networks, what is the input, the hidden layers, the output, what is the actual output, one-hot encoded vectors, how we're going to find loss functions inside the artificial neural networks, what are the connections, what are the weights, and how it's trained, what is the optimization algorithms we are used inside the artificial neural networks. So we had one session, the first part of our workshop was talking about the structure of artificial neural networks. After that, we talked about generative models inside the AI. We talked about 3 different models. The first one was an autoencoder, how an autoencoder is divided into 2 different algorithms. One is the encoder and the second one is the decoder, and how they could they could get an input of an image, and they could generate a new image with downsampling and upsampling. And as you can see, the bottleneck is called the latent space, and we could just create a new representation of our data. And what we do in architecture, we could have 2 different kind of data. One is the vector data, and another is raster data. We talked about this in the workshop, how we could change these data to numerical calculations, because everything inside AI is done with numerical calculations. After that, we talked about autoencoders, how we could change the original image to a new representation of image, and how we could use this inside architecture, also denoising algorithms. We talked about this. And for example, how we could give a 3D model without a render to an autoencoder and receive the render in just 1 second. Because what we really do inside the rendering, for example, in V-Ray, we have some rule-based CG equations, and it takes a very long time. So inside the AI, we could quickly generate the renders of our 3D models. Or we also talked about segmentations, semantic segmentation inside architecture. For example, we could write an app on our mobile, and we could easily segment different kind of furnitures or different kind of buildings inside the picture. We could easily segment, for example, the churches from the villas, and could easily distinguish this. And then we talked about neural in painting using autoencoders. If you like to complete an image that we have, we talked about this in our workshop. And we also talked about the usage of the application of autoencoders inside the neural in painting of architecture, the facades. And then we talked about a new model inside generative design called Variational Autoencoders, which we could pick a sample from a distribution of the manifold in the latent space. So these are some synthetic faces. They're not real. They're created by variational autoencoders. And then we talked about the generative adversarial networks, how they work, what is the generator, what is the discriminator, and also about latent space. And we talked how we could use this inside the architecture. As you can see, again, these are some synthetic faces. They're not real. They're generated by computer. And all of these interior designs are generated by computer. They do not exist. And all of these are done based on a data-driven processes. So you should have a big data set. You give it to the artificial neural network, and it trains on this data set, and it could generate new synthetic data based on the data set that you have given to the computer. Finally, we start to coding this inside Python. Fortunately, all of the students and participants could catch up very quickly. And we had a very simple task in the class. We generated some synthetic numerical data, and we could extend this to inside the architectural domain. And again, in another part, we start to code some, because we have two different AI algorithms, weak AI and strong AI. The weak AI is something like genetic and optimization algorithms. We also started to coding some optimization algorithm inside the Python in Jupyter. And we talked about how we could connect this Jupyter and scientific coding inside the Python to our interface, architectural interface, and how we could change the data of architecture to numerical data in the Python. Finally, I want to show you some applications of AI generative design. This is before and after the training. You can see we could input the 3D model and receive the render after the training. Also, we can give the hand sketches to the generative model and receive the render out of the hand sketches very quickly in just 1 second. We could also predict the design of an architect based on the style transfer models. For example, we want to predict if Frank Lloyd Wright would have an empty site and we want to design a new house. We could predict how would Frank Lloyd Wright design this new space. We could also predict the human's movement, the simulation of the crowd behaviors very exactly. So I could just say more than 90% correctly, and we could just do that with generative design models. So we could see we could use AI inside the design analysis and also in the prediction of what is going to happen inside our building. Or we could also use the rule-based designs, the high-level constraint designs and the generative design to generate some architectural layout plans. We could just give the boundaries and say how many rooms we want, and could give us a heat map of probability of where each place could be located. I want to address a movie here, The Impossible Things. It is the world's first feature-length film co-written by AI. There's lots of papers nowadays that are written all by AI. And we can also use this AI in every field of architecture and design analysis and prediction. For example, in the lecture prediction, we could give the 20 years lecture of Peter Eisenman to the AI, and we could predict what he's going to say in the next lecture. Or also we could predict the next eCAADe, what's going to happen in the next eCAADe, based on the 36 years of the trend that we have. And finally, I want to thank all of you and all the participants that came to my workshop. Thank you.